Section 3.5 Mesh Analysis with Current Sources. In the previous circuit, we find there is no current source at all. What if there is a current source or more than one current source inside this circuit? Can we still use mesh analysis? Of course we can use it. We are going to learn the situation with current source with two steps. For case 1, when a current source exists only in one mesh, just as this circuit is in the graph, and there is only one current source, and this current source only in the mesh 2 but not in mesh 1. In this case, it's very easy to deal with it, and we can get I2 equals minus 5 amperes, which means the current of the mesh 2 equals the current of this current source. Case 2. When a current source exists between two meshes, that means there is a current source belong to both of mesh 1 and mesh 2. In this case, we create a super mesh excluding the current source and any elements connected in series with it. For example, in this circuit, there is a current source with 6 ampere current, and it is in the common branch of mesh 1 and mesh 2. In this case, we are going to form a super mesh. The super mesh excludes 6 ampere current source and the 2 ohm resistor as well. And then we can use KVL to get the equation, which is minus 20 plus 6 times I1 plus 10 times I2 plus 4 times I2 equals 0. And we get one equation, but we have two variables, so we need another equation, and we can get the equation like this: I2 minus I1 equals 6 amperes. So we can solve the equations and get I1 and I2. So a super mesh results when two meshes have a dependent or independent current source in common. And now, what are the properties of a super mesh? The first one, the current source in super mesh provides the constraint equations necessary to solve the mesh currents. The second one, a super mesh has no current of its own. The third one, a super mesh requires the application of base KCL and KVL. This is the end of this section.